All right, in this video we're going to talk about the quantile approach to data classification. Remember, in an equal interval, what we said was that the interval for each class would be the same. That is, in our example data, that would be 318 was the top end of the first class, and then each subsequent class added 318 as a value, so in other words, our human population. Now, in this case, what we're actually doing is our classes are not based on values, but rather an equal number of enumeration units in each class. So in this case, what we do is we count in a sense that we order every enumeration unit, so in this case, every block group, from the smallest population to the highest population. And then we count the total number of enumeration units, and we determine an equal number of enumeration units in each class. So in this case, if we have 1,000 block groups and we want 5 classes, we're going to have 200 block groups in each one, regardless of what the actual values within each of them are. So in other words, we will order them. Remember our ordered data when we talk about levels of measurement. But in this case, that ordering is going to allow us to break each class into an equal number of enumeration units. So again, if we think about kind of how this is done, we order all of the features, highest to lowest, and then we break them into the total number of features by classes. So again, simply an equal number of enumeration units in each class. And then the classes are assigned based on those. Now, the disadvantages of this approach are that we may have features. In other words, if we order features and it ends up that one of our block groups has 318 people in it, and the next block group up has 319, if that is the divide between classes, we're going to put that divide there, even though those are essentially the same values or very similar. In a like manner, kind of the flip side of that, is that at the other end, values that are very, very different may end up in the same class because they are at the top end or at the bottom end of our data. And so we'll see that in our example. So let's take a look at our data, and we're going to look at a couple different things here. So in this case, we have a quantile distribution, and I'm going to open up the legend here. And you'll notice that in the first class, we have all of the values that are zeros. Okay, so we have enough of our block groups that have 0 population in it that they fall into a single class. The next class has 1 to 22 in it, 23 to 56, 57 to 115, and then 116 to 1591. So if you think about that, in our first 2 classes, we have very little variation in the total population. In the top one, in fact, it has produced our greatest variation thus far in terms of the population range. And so it's really good at seeing what's happening in kind of the middle area. The other thing that this allows us to do is say what are the lowest 20% of the block groups, what is the highest 20%, and then we can in fact divide it into equal 20 percentiles. Now, again, if we look at our histogram, we'll take a look at our properties here. What we see in terms of how the break occurs is that you'll notice at the low end, right here, we have a number of classes right down at the bottom that really are essentially right on top of each other. But this last class is immensely wide. And again, we've kind of lost a lot of our information there. And so that does have an impact on how we visualize the data. But again, the quantile method is very, very good if we need to break our space into equal units. Now, the downside to this, the other thing that you might see on this map, is that while we are talking about equal number of enumeration units, we're not talking about an equal area. And in this case, you'll notice that in our highest class, we have a lot of small units, and so they appear in one class, whereas in the lowest unit, we see, because those are large areas, they appear to occupy a disproportionate part of the map. Now let's take a look at what happens with quantiles when we have a somewhat more normal distribution. And so again, let's open up the histogram and see what happens in terms of these breaks. And because the actual values are less important in a quantile approach, we still see a little bit of this kind of bias at the lower end and at the upper end. And so again, this is somewhat less affected by the distribution and much more affected by the size or the size variation in the enumeration units. Okay, so that's again the quantile approach. Very important if you wanted to break values into area-related percentages. Not so good if your data has a significant spread to it on one end or on the other. All right, next time around, we'll be looking at standard deviations.